Hello, class. Today we're going to be talking about transversals and auxiliary lines. Um, this lesson is very much related to the lesson that we did yesterday and the day before that when we were learning about transversal lines. So we're going to first activate your prior knowledge, what we learned over the past few days, and I'm going to ask you some questions and you're going to answer them. Okay, so we have these two lines and a line that crosses across those two lines. Now, these two lines, I'm going to mark them with the two arrows going in the same direction. Who can tell me what that tells us about those two lines? Good. These lines are parallel lines. Okay? Parallel lines, even though two lines may look as though they're parallel, we don't know that they're parallel in math unless they're marked by these symbols that show that they're parallel. Now, who can tell me again, what does parallel mean? Good. Parallel means two lines that go on forever and never cross. Excellent. Now, that brings us to the point of transversals. Can anybody tell me, if they remember for 30 points, what is a transversal? Very good. A transversal is this line right here that crosses over two or more lines. Now, a transversal is just one line that crosses over two or more lines, like we learned before, okay? It doesn't have to go across two parallel lines, but we've been working on in class is special rules that have to do with a transversal that cuts across two parallel lines. Remember that. The lines have to be marked as parallel. Okay, so what did we learn? We learned about angle relationships. I'm still activating your prior knowledge. So we learned that angles that are across from each other are equal. Even if they're not marked that way, these angles are equal. Same with these angles right here. These angles are equal because they're across from each other. That's just one of the rules. Can anybody tell me the other rule? Good. The other rule. Two angles that are not across from each other, that are next to each other, which we call adjacent to each other, these angles always add to 180 degrees. These two angles all add to 180 degrees. All right, so that was us reviewing what we've already learned. Those are the three main rules so far that we've learned and gone over yesterday. Now, the next thing that we're going to talk about is auxiliary lines and what they have to do with transversals. Now here, do we have a transversal? We do. Our transversal line is bent. Okay, but we do have a line that crosses two other lines. However, in order for our special rules to work, we have to have it look like this shape. Sorry, in fact, I'm going to correct myself. This is not two lines. This is two line segments that meet in the middle. Okay, it's actually not one line. Okay, if this was one line, it would continue, and if this was one line, it would continue. Okay, well, my first inference is I'm going to look at these two graphs and do they look similar? Well, no, not exactly. So we're not going to be able to say anything about much of the angles, but we will be able to say, if we take a look at the actual graph itself, the text, just like in English when we have a text, in math, we have a diagram. If we take a look actually at the diagram, the text, what can we infer from the evidence that we have in front of us? Not what do we think, what can we infer? Now, we know that two angles across from each other are always going to be equal to each other. These two are going to be equal, and these two are going to be equal to each other, although they might be different from each other. Okay? At this point, that's pretty much the only thing that we can know. We can also know that two angles next to each other are adjacent, or add up to 180 degrees. Okay, adjacent angles add up to 180 degrees. Okay. However, what we're trying to do with this diagram is we're trying to make this diagram look more like this one. And that's where the auxiliary line comes in. The auxiliary line, I'm going to erase everything around this so that I can show you very clearly what an auxiliary line is. An auxiliary line is a line that is not there until you add it yourself. And you add it to take a complex shape, let's say like a diamond, and you put a line through it to separate it into two triangles. This line right here, which is always dotted line, if you add it yourself, is called an auxiliary line. We're going to do the same thing, and we're going to put our auxiliary line right through the center point here. Now I'm going to erase this diamond, and I'm going to show you what we just did. By putting in our auxiliary line, now we can separate this diagram into a top section and a bottom section. You see, I just took my auxiliary line and I split it right down the middle, and I have a top section and a bottom section. Now if we compare this top section to this diagram, it looks very similar. This and this. The only thing that we'd have to do is we'd have to extend this line. Then they'd be the same thing. Okay? This diagram is the same way. We cut this diagram in half, and now we have the same thing. All right, now we talked about making inferences, where we can look at the diagram and we can use evidence to make not guesses, but educated guesses about what we know about the diagram. Now, with this auxiliary line, there's a lot more that we can know about this diagram than when it wasn't there. And we're going to take it and we're going to make inferences about the top and the bottom. Now, our inferences are based off of what we already know. So we know that angles across from each other are going to be equal. We know that angles next to each other, okay, like these two, angle 1 and angle 2, are going to be adding up to how much? 30-point question? Good. 180 degrees. All right, so now what we've done is we've used auxiliary lines, and what we previously know, and we've shown how auxiliary lines are very helpful. Okay, now the third technique that I'm going to be using is making predictions. Okay, now what do you think that we're going to be solving for? If we think back on what we've been solving for in the past, we've been solving for angles, okay? We've been solving for congruent angles. Tell me what congruent means. Very good. Congruent means equal, equal in measure. Okay, we were solving for congruent angles, and we were also solving for supplementary. Who can tell me what supplementary is? Okay, what does supplementary add up to? Two angles that add up to something. Good, they add up to 180 degrees. Two angles that add up to 180 degrees. Do they have to be next to each other? No, they do not. Okay, so our predictions that we're going to be making, we're going to be looking for those types of angles. So when we're making a prediction, we're not just going to make a prediction based off of nothing. We're going to try to remember where we are in the unit. What is this unit about? It's all about angles, parallel lines, and auxiliary lines now. Or sorry, transversal lines, and we added in now an auxiliary line. The whole point of making a prediction about what we're going to be looking for in this diagram, what we're going to find there, is because it's going to be always related to what we were doing beforehand. Beforehand, we were looking for angles. Here, we're looking at all the angles. So my first task that I'm going to give you is I want you to mark all the angles in this diagram, just like this. I'll do it in green. Okay, mark all of these angles, and then I would like you to make a prediction about which angles are going to be equal and which angles are going to be supplementary. Now after you do that, I also want you to make a prediction about how many degrees you think each of these angles is going to be. And then we'll be taking our protractors and we're going to be measuring these angles as well. All right, well, that's your task for right now, and then we'll convene again and we'll go over what we just did, and we'll show that our measurements and our predictions, maybe we'll be able to confirm them and come up with some rules.